Hello friends, welcome back. In this episode we will see the classification based on molecular forces. Based on molecular forces, polymers are classified into elastomers, fibers, liquid resins, plastics. In this plastics, these are polymers again divided into thermoplastic and thermosetting plastic. Before entering into this in detail, we'll see first of all which forces will govern the mechanical properties of these polymers. They are van der Waals forces and hydrogen bonds. These are weaker forces, hence these intermolecular forces will help the polymer to be formed by using molecular forces. Now in detail we will see these categories. First of all, let us see the elastomers. As the name indicates, these elastomers has the elastic properties. They are rubber-like solids with elastic properties. For elastomers, best example is rubber. In this elastomeric polymers, these are elastomeric polymers because elastomers, the polymer chains are random colloid structure. How the polymer chain will be formed is random. Already we have seen the types like random, alternating, and in copolymers we have seen the four different types of polymers like bulk and also joint. And this elastomeric polymers have random polymers. It has colloidal structure. They are held together by weakest intermolecular forces, as we already have discussed, like van der Waals forces and hydrogen bonds are present in these polymers. So they are highly amorphous polymers. Here it is amorphous, not crystalline. Amorphous means it will be in a powder form. And these weak bonding forces permit the polymer to be stretched. Due to these weak van der Waals forces or hydrogen bonds, the elastomeric properties of the polymer to be stretched is due to these weak binding forces. Few crosslinks are introduced in between the chains which help the polymer to retract its original position after the force is released, as in vulcanized rubber. Example is vulcanized rubber. As we seen in vulcanized rubber, because of the cross links between the chains, the elastomeric property, when the polymer is released, it comes to its original position due to cross links. Due to weak binding forces, the polymer will be stretched, and due to cross links, the polymer will come to its original position. The best examples are Buna S and Buna N, neoprene, etc. The artificial rubber is also called as Gatta Pacha. This is its chemical formula. In this transform, we will see the rubber will be in the transform is called Gatta Pacha. And now we will see the other one, fibers. Fibers, as the name indicates, it has the fibric property. It means it will be like a long filamentic type. Fibers, if drawn into long filament like material whose length is at least 100 times its diameter, means polymers when they are stretched, its length should be at least 100 times its diameter than its original length. It should be 100 times more. Those polymers are said to have converted into fiber. And the next property is polymeric chains or straight chain polymers. These fibers are straight chain polymers. They are held together by strong intermolecular forces like hydrogen bonding. These strong forces also lead to close packing of chains and thus impart crystalline nature. Here, whereas weak bonding gives elastomeric properties, here whereas strong bonding forces gives crystalline nature. They are amorphous and here crystalline. Whereas in elastomer we have seen the amorphous property, that means it will be in a powder form. Whereas these fibers will be in a solid form, that is a crystalline nature. Fibers are thread forming solids. What are the main definition for these fibers are? They are thread forming solids which possess high tensile strength and high modulus. It has high tensile properties and modulus will be high. Examples are nylon 66 and terylene. Next one is liquid resins. Polymers used as adhesive, potting compounds, silanes, etc. in a liquid form are described liquid resins. Means main liquid resins means it has adhesive property, means attached properties should be there. We all know adhesiveness, lubricant properties, but here it will be not like a lubricant, it will be adhesive, means it can attach to some other polymers. Potting compound, sealing, etc. in liquid form are called liquid resins, where as the name indicates, liquid means water type. If the polymers such as adhesives etc. will be in a liquid form, then it is called as liquid resins. For this, examples are epoxy adhesives and polysulfide sealants. The other one is plastics. A polymer shaped into hard and tough utility articles by the application of heat and pressure. It is used as plastic. By using the heat and pressure, and articles which have a tough and hard utility shaped polymer, it comes under plastic. The intermolecular force between polymeric chains are intermediate between elastomers and fibers. Its property and its force, it will be present in between elastomers and fibers. So they are partially crystalline, means somewhat a little bit solid property will be there. Typical examples are polystyrene, PVC, as in PVC pumps also is the best example. Polyvinyl chloride and polymethyl methacrylate. These plastics are of two types, thermoplastic and thermosetting plastic. We'll see what is meant by thermoplastic and thermosetting plastic. First of all, thermoplastic. Some polymers soften on heating and can be converted into any shape, and they can retain on cooling. Means if for example we take any polymer, on heating it can be converted to any shape as we wish, and then on cooling it retains to its original shape. The process of heating, reshaping and retaining the same on cooling can be repeated several times. This process can be repeated for several times. The polymers that soften on heating and stiffen on cooling are termed as thermoplastic. These polymers which can be softened on heating because we can retain it to any shape and stiffen on cooling. On cooling it will become as a harder substance. This property of plastic can be called as thermoplastic. These polymers possess intermolecular forces of attraction between as the plastics we already told, its property lies between elastomers and fibers. It has linear, slightly branched long chain molecules. Examples are polyethylene, PVC, polystyrene, nylon, etc. Soften on heating and harden on cooling. This plasticity can be reversible, whereas in thermosetting plastic its property cannot be reversible, and it can be soluble in some organic solvents, as we have already seen. The van der Waals forces of attraction will be held in these polymers. Next one is thermosetting polymers. These thermosetting polymers In this, they undergo some chemical change on heating and convert themselves into an inflexible mass. For example, egg yolk. If you will see the egg yolk also, it will be it will undergo some chemical changes on heating. If you heat means it becomes into a solid type and convert themselves into inflexible mass. It becomes a like mass like substance. Such polymers are harder, stronger, and more brittle than thermoplastics. They are harder and stronger, more brittle than thermoplastics. They are insoluble in almost organic solvent. That is, organic solvents, it is insoluble. These polymers are cross-linked and heavily branched molecules, whereas thermoplastics are not heavily branched, whereas here they are heavily branched. They are linear, they are cross-linked, which on heating undergo extensive cross-linking in molds and again becomes inflexible. They cannot be reused. Example is bakelite, urea formaldehyde resins, etc. Thank you.